Okay, everybody, and thank you very much for coming around and watching this video and liking, hit subscribe. Now, in the last video, we talked about the stuff for XML and what it can save and what it doesn't know how to save. So, today's code is, well, not really code, is going to be about binary saving. Okay, sounds very boring and everything else, but it is going to come up to a very good conclusion and stuff that Unity has a hard time dealing with and the problems that you're going to run into. Now, binary is a language that you cannot read. It's all written in computer code. Like, I'm not talking about words, I'm talking about like very crummy looking stuff that isn't readable. Okay, a lot of games use binaries for serialization because it's very difficult for people to just go in there and fiddle with stuff. XML is readable. Okay, you can read it. It's readable in every standards. You can go in there and tweak variables like floats, bools, integers, strings, add stuff to the array, give yourself weapons, whatever they got XML feeding into the system, you can manipulate like crazy. Binary, on the other hand, not able to do it because it's ones and zeros and funny looking other signs and good stuff. Is unreadable. Unreadable. And XML is readable. Okay, so what is the stuff that we can do with a binary formatter? Well, the big plus is definitely it's not readable. But what about this other stuff that it can do? Can it do floats? Floats! Yep, it can do floats. Okay. What can we save? Boop. We can save floats, bools, enums, okay, and we can save strings. Why does that not look right? Because I don't think it's got, wait, strings. String. Yeah, that's right. It's got an R. Okay. Alright. Strings. Okay. Alright. Crazy. It can save integers, arrays, and lists. But the one difference that's really nice is it can save a dictionary. Now you're probably thinking, why is a binary formatter can save dictionary, but an XML cannot? Well, here's the thing. Binary can save a dictionary as long as it's something that's serializable, like floats, doubles, integers, and things like that. Okay, serializable stuff. Okay, if you stuff a dictionary with GameObject references, quaternions, textures, images, or, like I said, prefabs, it's not serializable anymore. The XML doesn't know what to do with the dictionary. And I think a lot of it is because XML is supposed to be a very simple language. And dictionaries, I believe, are iterators. It's an iterator. A dictionary is in the collections, and I believe in itself it's a iterator. Right? I believe it's a form of iterator, that's why. And it doesn't know what to do with that type of iterator. XML is supposed to be used for like simple stuff, okay? Not anything that's complex whatsoever. And the difference between both of them, they say binary because it's binary and it's automatically what the computer's code is. Well, okay, let's slow down. Let's get my ADD to slow down here. Binary is the native code that's pretty much used in a computer, where XML is our language and it's got to sit there and parse. Well, guess what? The binary, when it's saved, it's already in the language that's native to the computer. So a lot of times, if there's big information, binary is the way to go because it's already native to the computer. It's like if you speak English and you want to go to French, well, that would be XML, right? Because it's going from one language, which is binary in itself, where the computer understands it, and goes to another where we can understand it because we're French or something like that. But binary is native, which is the computer's language, okay? And we're just pulling it out and putting it into language that's computer, you know? It's very, very, it's like speaking to somebody who's English to somebody who's speaking English, okay? Very quick and responsive. We don't have to interpret, all right, where XML has to interpret. So this ends up being faster. But there's a few things that kind of suck about it. And we'll get into it. And a lot of it has to do with how files are opened and closed, okay? But binary can do a dictionary as long as it's a serializable thing, okay? An array of floats and things like that, an array of bools, arrays of... We can also have classes, but the classes have to be serializable. We can also do that in XML, but we'll get into that. So this is stuff that we can save, but a binary has a problem. It can't do vector 2s and vector 3s without manipulating it, okay? We have to do something else to get vector 2s and vector 3s in there. It can do lists and stuff, but it can't do that. So what can't we save? Well, I know it's a pretty poor explanation and stuff like that, but what can't we save? Well, we can't save a game object. That's stupid. Okay. Images. Okay. Textures, which are different. Images are images. Okay. Textures can go from 2D to 3D. It's completely different. Okay. It's not something that's like not important to say. A quaternion, definitely there. We can't save a vector 2 or 3. Okay, so in prefabs, okay, Can't save it, can't save it, can't save it. There's probably some other stuff. Oh, and just in case, transforms. No, transforms is pretty much a game object. I mean, you can't really expect not to be able to. Components like colliders, you can't save those things in any type of language because it's something Unity's involved with and stuff. You can't save colliders, game objects, you can't save, quaternions you can't save, textures you can't save, references, that's pretty obvious, you can't save them. Let's see, what else could there possibly be? I know I'm probably forgetting like a whole bunch of things that you just can't save. And you're probably like, well, how are these guys saving this crap in a game where you can drop weapons on the ground and they're always there? Things. It's because they're customizing the serialization. Okay? They're pretty much customizing the crap out of it. Okay? So there is a few ways of getting around this. Now, the dictionary thing, well, let's go to the game object. How can we get around the game object stuff? Okay, for XML, ran it. We already know we can't do a public game object prefab. Okay? Well, there is a way around that. Okay? And it's called resources dot load. And you can load a string.path. Now, by default, it goes to the prefab equals resource.load, and we'll load this as a game object because we have to tell our stuff what it is. And then you can put a string in here. And we can put this prefab. Okay? And this will load a game object in there. But we have to fill this string in. Okay? Which kind of sucks because now we have to have another variable which is called prefab name. Okay? And this has to be public so we can do it in the inspector, right? And now instead of putting that there, we can put this here. Okay? So whatever we put in the inspector, it will load it up through here. So, by definition, we no longer need this, okay? And you're like, well, when we go to XML and stuff, most likely we're going to have a class, right? So my class, and since we can't do a game object, we're going to have a public string prefab name, right? So we got a public string prefab name. Okay, so we'll probably load up something like this and get our game object out of that. Okay? And this is how we can fill this variable in. Now, because, and remember, XML, what can we serialize? We can serialize a string. Also, in binary, we can serialize a string. So when we go into saving, all we have to do is do this string name. Now you're like, well, what about the other stuff? Well, the other stuff we need in an XML, we can save vector3. Okay? So, but in a binary, how can we get around the problem with not being able to save a vector3? Well, in binary, we go in here and we do a class again, and we'll put this XML vector. Okay, so XML vector. Now, if you remember, these have to be public, float, x, public, float, y, public, float, z. Okay, and to make life easier, we're going to put a public thing like this for the default constructor. Okay, and then we do a public and we're going to customize the parser here. Now this is going to have a vector3 position well, that doesn't look right. Is it? Okay, doesn't matter. So it can't save a vector3, but we can feed it into an overloaded method. And all it's going to do is x equals position dot x, okay, then y equals position dot y, and then z equals position dot z. Okay. Now, in order for this class to be serializable, you must put in here an attribute of system.serializable. This must be here and here. Okay. The class also must be public so it can be accessible to the serializer. Okay. So now, anytime that we have a thing here for vectors, we will have to put XML vectors pause equals new, and now we have an overloaded method that will take a vector3. and we can put new vector 3, and we can put 1F, 1F, 1F. And this is before the program starts, and remember, this must be public. But like I said, this is serializable now, so you can do a vector, and when you do saving and stuff like that, you can always feed it a game object and things like that. But resource loading has its limitations. It must always have a string, and this can be parsed out to different things. So if you're trying to load up a texture through resources.load, and you've got hard-coded like this as a game object, it will throw an error because you can't parse out a texture from a game object. That's just crazy, right? So there's a lot of that. Now you can load up a type. I won't show you that, but I would read up on the resources.loading, because it's really, really great for certain things. So the resource loading in our thing, we know how to do that. But how are we going to look up something like that? Well, you basically have to feed it a string into the serialization for this. Okay? So basically, you probably go something like a game object spawned into the world. Okay, and then somewhere in your thing, you're going to have an example of a void save, right? You're going to have a void save method, and this one we're going to put a game object. Spawned. We're going to put in game here. We're going to call this in game. Okay, so somewhere in there you're going to have this loaded up and everything, and you're going to call saving, right? Well, saving is you're going to call save, and then we require a thing, which is spawned, or spawned in prefab. So this is calling it up, and we're going to call, this is just an example, okay? So now we've got this game object here that we're referencing, and we want to save this stuff into the serializer. Well, here's the thing. We already know what it is, because it's the prefab name. We can't spawn in anything that's not the prefab's in. So you've got the spawned in. This is it. And this is the reference. So this is in-game and everything. Well, now you got to customize how this game object is getting serialized. Well, we need a name, and then we need to save the position, right? That's wrong. Well, we need to go my class, save file, and this could go for binary or anything else, equals new, not minus, equals new. Okay, now we have this. Okay, so we've got a new version of it. So we go save file dot prefab name equals prefab name, or prefab name. That's up here because we loaded up the resource, the game object, and we got returned the game object, okay, from this string. So it's predefined, it's hard-coded in there. Whatever we put in the inspector for the game object, it's going to give us this prefab. And then somewhere in the game we spawned it in, and we also called save, but we passed it to GameObject. So we already know that whatever this name is, that's the GameObject's name. Okay? So we got the name of it. So now we need to go save file dot position. This equals our in-game dot transform dot position. Simple as that, right? I mean, it should be. Oh, wait, position? Oh, that's right. Ooh. In-game dot. Okay, so how equals new. Yeah, we'll do it this way. We're going to get a new XML class thing in there, okay, which is just nothing but an internal class of this, because we're doing a reference. We want to use the function that I created to feed in a vector 3, basically. So in-game dot transform dot position. Okay, so I'll just create a new one and it'll be fine. It's just a vector. It's not that big of a deal. But that's how we can get this positional stuff to be in there. Oh, that's why I'm goofing off. We don't have to do a new one. We don't have to do a new one. All I have to do is go in here, do this, come out here, copy this. Instead of making this like this, make this a void so we always have access to this. And now we go in here and not that. And now we can go in here and go save file position, save file dot position dot vector, and it takes an overload now. So now we can go in here and go in-game dot transform dot position without creating a new class of it every single time. Now you're probably like, what's the difference? Well, the difference between these is telling C# how to serialize this stuff, okay, with these things right here. So it's wanting the new class kind of stuff, okay. This is a regular void. This is nothing but like on enable, on it's nothing but like how you go public. This would be public and you'd hit save. No different. Okay, this is just a regular function. It's not public, but we're making a public function just to fill in this stuff. I mean, you've done it hundreds of times if you program stuff. This is just predefined stuff of how you can create a class. This is the class is created and you're trying to manipulate or call a function inside of it, which this function actually is a vector. So we take a vector 3 and fill in this information, and that's basically all that we did with it, because it already exists when we created this. Okay. So now we've got an in-game, when we feed a game object in here, we can pretty much save this out to a file now. So the binary and the XML will be able to save this already, but the limitations is we have to use resource.load. And if you're not familiar with resource.loading, let's look in Unity real quick, because this is where we're going to end the video. Resource.loading requires you to have a folder and then game objects in the folder right here. Okay. So anytime you want a prefab or a game object of some kind, you put it in the resource folder. Okay. And that is resource.loading. So let's say we want my thumbnail maker here. Well, guess what? We put it in a resources folder and bam. Then I can load this up at any time right here. And, you know, it would just instantiate it and we give a position and stuff like that. And that's how the world works. It works just like a regular thing. So I'm going to end the video here because it's extremely long and some people don't like long videos, but I hope you enjoyed the explanation between the XML and the serializers and stuff. Now, I'm not going to lie to you, it really sucked, but we had to get through it so that we can learn the limitations of serializing. I know it's kind of a crappy subject and hit or miss, but we had to do the ups and downs of it. The next video, I promise you, is going to be a little bit more interesting and things, because we're going to take what we learned in the last two videos, in this video and the other video, and we're going to apply it inside of Unity. But I'm going to show you a different way of doing something with our inventory system and a lot of other things that's going to be really awesome. You're going to love it. Okay? Trust me, you're going to love it. So remember, guys, to like, hit subscribe, and if you haven't hit me up on Twitch and stuff like that and follow me every once in a while. It hasn't been a while. I get on Twitch and I start coding a lot of times in there, because then you guys can chill out and, hey, what's up, war? You know? So thanks, guys, for watching. Peace out, everybody, and I will see you in the next video where we look at some other stuff that's not XML and binary stuff, but we're going to be able to apply those things in other types of situations, but we do need to make sure that we go through that stuff. So, like, hit subscribe, and peace out, everyone. Thanks for watching.